In this video, we're going to take a look at how we can relay traffic from an Android application through a proxy, in our case Burp Suite. So we'll look at how to set that up, and then once it's configured, we'll check out some of the things that we can do with it. Let me just start by saying that although this is a video series on Android pen testing, I'm going to try and make each episode self-contained, so you don't need to have watched the previous episodes for it to make sense. There will be a clear defined objective for each video. That being said, of course, if you're going through a video and nothing is making sense, it's obviously a good idea to have a look at what the previous episodes were about and see whether you need to catch up on some of those fundamentals. And in that spirit, let me just give a quick recap of the first episode where we gave a general introduction into Android hacking, and we talked about some of the practical labs that were available. One of them is this InsecureBankv2, which, although it's not a particularly recent application, it does have a lot of mobile vulnerabilities covered, and if there are any other vulnerabilities we want to cover in an episode, we can easily pick another application or a CTF challenge or something like that that can demonstrate what we want to show. Okay, so make sure you've got this Git repo cloned, like I have at the moment, and we'll have an APK in there. We've also got a usage guide on how to set this up and some walkthroughs and stuff as well. And we've got this Andro Lab server, which we do actually need to run, so I'm going to go into that folder. And we've got app.py. If I do python app.py, it's going to run into this error because it's using a Python 2 script. It's quite old, as most of these applications are. And if we do Python 2, it's going to want to install this module. And then if we try to do python 2-m pip install, that's not going to work for me anyway, the way that Python 2 is set up on Pirate OS. So you can use a virtual environment, or you can go and change this to Python 3. Now what I normally do in that case is use 2 to 3, and then you can basically pass in the script and then say you want to write the output, and it'll convert all the Python 2 stuff to Python 3 stuff. However, that didn't work for me in this case because there was some issues with like spacing and indentation, and rather than debug it manually, I just went back to the Git repo and had a look at the pull requests. Because with an old repo like this that's no longer maintained, quite often you'll have somebody that has come along and said, I've updated this to make it work with the latest libraries, and here's the changes that I made. And that's exactly what happened here. So we've got this commit, we've got a file which we can just go and replace our app.py. Alright, so where are we? View file, get the raw. Gonna take a copy of this, and then I'll just open this up, app.py, replace that, and then let's try it again. Python app.py, no module named web. Okay, so we also need to do some installs. Let me do pip install. Alright, and let's try and run that again. Python app.py. If you get any other errors here, just do the pip installs, and you can see this is now running on port 8888. So with that running, let's open up Android Studio. We looked at this in the previous video, and one small change that I made since then was with the Android Device Manager. So let me open up the Virtual Device Manager, and you'll see we've got this integrity device with Android 9, API 28. So remember, if we want to use the mobile security framework with dynamic analysis, which we saw again in the previous video, then we want to use an API 28 or below. The change that I made here was with the actual system image that was used. So you can see here it is Pi, and it's 64-bit, but it's Android 9.0 rather than Android 9.0 Google APIs. If we use this one, the Google APIs one, then we're going to have some issues because it's basically not a rooted device. So just bearing in mind, you can have many of these different systems, so it's fine to use multiple, but for some of the pen testing stuff that we'll be doing, we'll want to make sure we're using a non-Google APIs image. And that's the only change that's made here. So we can go in here and say we want to profile or debug an APK. We'll double click this. I've already opened this up before. I'll just overwrite the existing project. And it's disassembling the classes.dex. Remember, we talked about the Dalvik bytecode in the previous video as well. Don't worry if you didn't watch it though, we will go over this stuff again. We've got our files here on the left. We've got our device up at the top. We can run it, we can debug it. We can change the device that's used. I've only got one at the moment. And also the configuration. So that's fine, let's hit play. Now one thing to note here is that you can undock this, so we can create this as a window, bring this over here, and so we've got a bit more space. I don't like this grey background, and I was trying to work out what had actually changed since my old version of Android Studio, but it's also an issue in terms of setting up the proxy. So if it looks like this, it's probably not a good sign. Because whenever we go and click these little buttons at the top, see it opens up these extended controls where we can go and change more things, and there's a settings option And this is basically where we would need to go to set up our Burp proxy, set up the certificate. And there's no option here for proxy at the moment. So that's something that we want to fix. And to do that, let me actually just go and let me close that. Go to File and Settings. We'll go down to Tools and then Emulator. And then you want to untick this option that says Launch in a Tool window. Click Apply, OK, and then let's try that again. I don't know, do I need to reload it? Let me try. Okay, that's still not looking good. Let me try and restart it. Try and run it again. It's already running. There we go. Alright, so you see we don't have that grey background now. And now if we go into these three dots and into settings, we'll see that we've got, first thing I'm going to do is change that to dark so we can see. But now that we can see, we have got this proxy tab, so we can go in here and basically set up our proxy. Similar to how we would do whenever we're using Burp Suite in Firefox, we have to go and set up those proxy settings. Very similar situation here. So at the moment, we've got a login screen here. We could go and try and put in some login credentials. Let's say admin, login. And it's come up asking us for the server and the port number. Go and have a look at Burp. We've got nothing in the HTTP history tab. Let's go and have a look at our server. Alright, so this is on port 88888. So we can go ahead and put in an IP here. I'm just grabbing the Ethernet adapter, but I think you could probably use localhost here. I didn't actually try it, but let's put in, you can't do Control and V there, so I'm just going to hit paste and then submit. Try and log in again. Invalid credentials, okay. And if we go and have a look at the server, you see here, user does not exist, user admin. So it looks like everything's working okay, and that's good. But if we have a look at Burp Suite again, nothing has been intercepted. So the first thing we need to do here is go into our proxy settings and go and change our proxy listeners. So grab this one, change it to all interfaces. Now, I'm not actually doing that in this case because I'm using Android Studio, but if you're using a real Android device or if you're using Genymotion, which would be like a separate virtual machine, then you'll want to have this set to all interfaces. Instead, this will just work on localhost, loopback only. So I'm just going to click OK, but we do need our certificate as well. Let's export the certificate in DER format. Next, and I'm going to put it on the desktop. We'll just call it Burp, and you want to save it as .cer. Save that. We'll go to Next, and there we go. We've successfully exported it. Alright, now we want to install the certificate. So I'm going to minimize this stuff. I'm going to go and just drag this Burp cert here onto the phone. Let's take away this screen, and we can now go into... Well, actually, there's a couple of ways we can do this now. We can do this through the phone, so we can just drag that up and go into our phone settings, and then we'll go down to security and location, and then encryption and credentials, and then install from SD card. And we've got nothing here. Let's go to our SD card. No, let's go to our downloads. There we go. There's a Burp certificate. So I'm going to double click that. OK. Just going to name it Burp. OK again. And it's going to say we need to set up a lock. So we've basically got to do that. So I'm going to go and do continue without fingerprint. And then I'll do a PIN. And I'll just put yes there to the secure startup. That's fine. We'll enter in a PIN and then go next. Confirm, and that's fine as well. Just hit done. Alright, Burp is installed. So the certificate should be installed now. Let's go ahead and set up the proxy. Let me go back to, actually, it's this window here. So our three dots, and we can go into the proxy settings. We'll go and do our manual configuration. Oh, untick that box first, of course. And then 120. This is going to 127.0.0.1 again. This will depend on how you've got this set up and whether you're using a real device, whether you're using Genymotion on a separate VM, and you want this to be set to whatever we have in Burp Suite in the proxy settings. So I've got this on localhost 8080, so that's exactly what I'm doing here as well. And that should be fine. Let's hit apply. Success. Alright, so our HTTP history is here. Now, if we go and run the app again, InsecureBank, alright, admin, login. And there we've got this post request to the login, which means we can go and do all the stuff that we do with Burp now on a website that we can just do on an Android device as well. So we could go ahead and send this to the repeater, for example, and we can go and start playing around with some of these values. Maybe we'll try some different passwords, maybe we'll try some different endpoints, and just all the same attacks you see really with a web application. Just before we play around with Burp, let's also have a look at another way we could have set this up. So we can use ADB, and we can do ADB shell. You can see this brings up the shell. We can do SU to go into root, and we can install applications and do a lot of things through this. So I'm not particularly good with it, so my first point of call is probably to go to ChatGPT or Google and ask it, how do we set up proxy with ADB? And it'll give us all of the commands. Actually, I'm using my personal account here for ChatGPT, so I didn't really anticipate how slow it would be. Let's leave that running and go back to Burp. So just in case you're not too familiar with Burp Suite in general, I generally use the HTTP history tab in the proxy, so whenever a request goes through, it'll show up here, and then we can have a look at it. We can send it to the repeater if we want to start modifying requests, or we can send it to the intruder if we want to start brute forcing credentials or something like that. We can also use this Intercept tab, turn that on, and then any requests that go through won't actually be sent to the server, as they will first come through to us to okay them. So we can either forward them or drop them or make some changes and then forward them. So I could now go and change the username and the password that's being sent and hit forward, but I prefer to turn this off and just use the HTTP history tab. What we will do now is try to fuzz through some credentials. So if I send this to the intruder, just like with a web application, but if you're not familiar with that, what we can do here is basically say what we want to brute force. So I'm going to add some markers to the username, and I'm going to go into the payloads and then load a usernames file, which, let me go to user share seclists and then usernames. And in here we can just grab a username list. Here's one with a default, this is the top 20,000 usernames. So I'll select that, and then we can also set up a rule. So in settings here, if you go to grep and match and see what was actually telling us, user does not exist. So that's what we're looking for. Go to the intruder, I'll paste that in there, and then we'll hit start. If you're not using Burp Pro, this will become exponentially slower over time, but it's fine for demonstration purposes. And these are the flags, so each one of these responses is coming back with the response saying the user does not exist. So we want to filter by that, and we want to keep filtering until we find a user that doesn't come back with that error. While that's doing that, let's go and have a look at ChatGPT, which correctly came back and said, alright, so we can use ADB devices. Let me exit this. ADB devices will list the devices. We've got autocomplete for this as well. And then we can set up the proxy. Basically just copy and paste this, and then we would change this to localhost or 127.0.0.1 on port 8080. And then we can verify the proxy's been set up like this. Let's see if we can do that here as well. Alright, null, so because it's not set up there, I guess that doesn't show in the ADB shell. Alright, cool. Back to our Burp Suite, and we've got a user. So we found this user, Jack, and the response came back and said wrong password. So now that we've got a user, maybe we'll cancel this and go back and change this. We'll say clear all those markers, and we want to just brute force the password this time. So I'm going to say the username is Jack, and the password we'll add those markers to. We'll go into our payloads and we'll clear this and add a username list this time. So we'll go loads and passwords. We'll do probable top 1575, and then we'll change the grep here to be wrong password. Add, so that's going to flag whenever we find a response that says wrong password, and of course we're looking for one that doesn't have that, so we just filter by order of by the size. So whenever we find one that has 0 here, that'll be the correct password. However, the password for this user and the user Dinesh is actually provided in the documentation, so this isn't part of the challenge per se. We're just demonstrating that this would be possible if this was a weaker password. The password isn't particularly weak. I think it's like jack at 123 hash exclamation mark or something like that. But just for demonstration purposes, this is something we might do to fuzz credentials or anything else. So what I'll do now is go autofill credentials. It actually says no stored credentials are found. Okay, so I guess we need a successful login first. So I'm going to go back to the Git repo, and we'll go and grab the correct password, which is jack at 123 $. I'm just going to make sure I don't grab that space as well. And we'll go back to the application, we'll put in here jack, and then I don't know how to copy and paste in here. If we open up this keyboard, does it work? I don't think that helped at all. Okay, normally it comes up with a option saying paste, which is not doing. Alright, so I'm just going to type it in. It is jack at 123 $, We'll log in, and then it should keep our credentials as well. Notice that it says the device is not rooted here, although by default emulated devices are rooted, but I don't know, do we need to make some changes here? We'll work it out, because in a future video we'll be looking at how we can bypass this root detection. So this app is basically checking to see whether the device is rooted, and there are some ways that we can bypass that in terms of patching the APK or using Frida to hook functions and some other options as well. So we'll look at that in future. But we log in, we've got this transfer option, we've got view statement. If we go and do get accounts, putting in an amount here, we'll do 999, transfer, and it says successful. Okay, so again, this is going through our Burp Suite, so we can see here do transfer. We've got get accounts as well, and it's coming back with correct credentials. Okay, so what if we were to do this transfer now and say send that to the repeater, and actually we want to transfer it from, and you might put in here then this other user that we had, Dinesh, send, and actually we get a server error there, so maybe that was because of the password. Let's try and undo that. Hit send, that works okay. What if we put in like -999, send? Alright, that says success, and it says that for -99999. Let's go back and see, can we have a look at the statement? View statement. Alright, so it didn't have the -99999 one. What if we go and just try that in this one? So we'll do get accounts, and then we'll do -999. And it does say transfer successful. Okay, let's try that again. Let's have a look at the statement. So we're seeing whether we can, by putting in a negative number, rather than us transfer money, the money gets transferred through to us. Doesn't actually seem to be any way to verify how much we have in the account, though, to see if that's the case. We've also got change password. So what we're basically doing here is looking for insecure direct object references. So an IDOR vulnerability would be like if we can enumerate, say, users in an application. So say we're given a user ID of 1 and we go to /profile/1, can we enumerate then thousands of those ID numbers and get through to other people's accounts? We shouldn't obviously be able to do that. Either they shouldn't be predictable, or should we say or they should have some kind of authorization checks. So just because I changed the name here from Jack to Dinesh, is there anything on the back end that's actually preventing me from sending money from Dinesh's account to another account? And that could be an issue with the password as well. So for example, if I go here and change password and say change it to admin, we click change password, it says not complex enough. Okay, let me put in a more complex one. It's kind of annoying that I can't use standard keyboard shortcuts here. I'll have to try and work out a way around that. Alright, so there we go, change successful, and there we get this message through as well, SMS. Now if I take the request, change password, and then send that to the repeater, am I authorized to do this for another user? Can I just simply change the username and then reset somebody else's password? Because that would be an IDOR vulnerability. Hit send, and it says that we can. So if I go back now, let's try and log out. We might need to restart the application, it was saying. Let's try it. Let's say Dinesh, and then let's try and put in the password that I just provided, which was admin, capital A, admin again, capital A, 123. We do that, click login, and we successfully logged in as Dinesh. So we've just exploited a IDOR vulnerability to reset another user's password without having authorization to do so. Now, one thing to bear in mind here is that we've set up this proxy and we've basically told the system that we want to authorize that burp certificate to be trusted and that we want to allow it to intercept our traffic because we have the control to do that as the owner of the device. However, we're going to run into SSL pinning in future videos where applications basically will say these are the trusted certificates that we use, and we're not just going to allow you to install your own and use it. So in that case, we would need to come up with some kind of bypass. And there are various techniques for doing that, which we'll look at in those future videos. But I hope this was a nice short introduction into how to set up a proxy, in this case Burp, in order to intercept and manipulate traffic from an Android application. In next week's video, we'll probably dive into the source code of the application and see if there's any other way we could have got logged in. So do we have any hard-coded credentials or secrets? Are there any hidden endpoints that we might be able to get access to, or are there any other methods for bypassing the login authentication altogether? One thing I will mention before I go is I found this link to a GitHub which has a list of CTF challenges that are mobile related. So some of them are write-ups, a lot of them will come with the actual APKs to download as well, but a great source of information if you want to learn more about the practical side of hacking Android applications. And that's going to wrap it up this video. As ever, if you have any questions or comments, leave them down below. Thanks.